All right, so we have one question for each of our speakers. The first one is for Paul Lucy from Gerardo Dominguez, who asks, could differences in the vapor pressures and surface binding energies of volatile carriers of N, S, and H alter those cometary or volcanic elemental signatures enough to complicate the interpretation of their origins?
Was that to me, Parvati?
Yeah.
Yeah. I mean, there are innumerable alteration processes that can change the signatures, and presume if they're volcanic and cometary, they've been there a long time. So that is a critically important question that really hasn't been addressed. I was sort of amazed, though, that the L-cross signature was so reminiscent of the elemental distribution of volcanic signal, which may mean that a burial depths of on the order of 10 meters may offer very long-term preservation of the original compositions.
All right, thanks, Paul. The next one we have here is from Margaret, and Andrew Feustel asks, how deep is surface ice and how deep is buried ice?
Oh, that's a really good question. So for surface ice, what we're looking at is the maximum surface temperature. So it's not going to be exactly at the physical surface because we're not observing necessarily in really short wavelengths with diviner data, but practically on the surface. And then buried ice, what we're using with the vapor diffusion model is saying that it would have to be within 1 meter of the surface. So that's kind of the short answer. The long answer is we're working with some thermal models right now to really understand the e-folding distance of the temperature wave to really nail down exactly what these values are. So stay tuned for that. Hopefully, when we write this up, that will be very clear with some supporting thermal models.
Okay, thanks, Margaret. And we have one question for Tyler from Kieran Carroll. Have you taken into account heat coming up from the lunar interior in your modeling?
Yeah, we have. So actually, the thermophysical model that we're using includes that subsurface heat flow, and also includes kind of the temperature-dependent regolith properties in Hall-Haynes thermal model. So we have kind of all of those in there. I think the heat flow isn't quite large enough to be changing the cold trap temperatures, at least in the scales that we're modeling on.
All right, thanks, Tyler. And I see a quick comment from Tim Lightergood, who says that a simple experiment for Viper might be to dig a small trench as an artificial PSR at the beginning of the Viper mission and revisit a few months later to see if any volatiles have accumulated. It would be interesting indeed.